Use the definition to find the derivative of f of x equals sine x, then evaluate f prime of 0. The first thing to do is write down the definition of the derivative. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. The next thing to do is to formulate f of x plus h. That means to take f of x, sine x, and replace every x with an x plus h in parentheses. Sine of x plus h. We'll subtract from that f of x, which is sine x, and all of that is over h. Now we have the 0 over 0 indeterminate form, and our goal is to no longer have the 0 over 0 indeterminate form. The only option we have here is the addition identity for sine. Sine of x plus h. So that will give us the limit as h goes to 0 of. The identity is the sine of x, the cosine of h, plus the sine of h, and the cosine of x. And then this is going to be subtracting the sine of x, and all of this is going to be divided by h. Now what I'm going to do is group together similar trig functions for the variable x. I have two terms that have a sine x. I'm going to group those together, and then one term that has a cosine x. This is in the numerator. The sine x's, I will have a sine x cosine of h minus sine x. And all of that is over h. Group those together. And then I also have a sine h cosine x, and all of that is over h. Now, each of these are 0 over 0. We haven't changed that just yet. What I can do for the first one is factor a sine x out, so I'm going to do that. So we have the limit as h goes to 0 of the sine x, and I will be left with the cosine of h minus 1 over h. That is still 0 over 0, and it's 0 in the numerator because of a trig combination, cosine of h minus 1. In order to take care of the trig combination, we have to multiply by the trig conjugate. So this first fraction, I'm going to be multiplying by the cosine of h plus 1, the trig conjugate, over itself, a form of 1, so that when we multiply, we don't change the value just to look. Now we have a second fraction, and that one will be cosine of x times the sine of h over h. Now the sine of h over h, we already have an identity for. That limit will be 1 as h goes to 0. So now we just have to FOIL out the conjugates for the first fraction. So we will have the sine x times, FOILing that out, will be cos squared of h plus cos h minus cos h, which will cancel, and then minus 1. Outside and inside terms always cancel, over the multiplication of the denominators, which we're not going to distribute or FOIL. We'll just leave it the way it is. Now this is added to the second term. Now after canceling out the outside and inside terms of that trig conjugate, we have a cosine squared h minus 1. And cosine squared h minus 1, from the identity sine squared plus cosine squared equals to 1. I will write that up top here, sine squared h plus cosine squared h equals to 1. We can rearrange this by subtracting a 1 to the left and subtracting a sine squared to the right, it looks like we can replace that with a negative sine squared of h. And then we have plus this second fraction, which we have a limit that'll be a 1, so we're just going to keep that the way it is. Now the limit is on h here, so we're not worried about the sine x. We have a negative, and we have a sine squared h. What I'm going to do with that is isolate it into its own fraction. And since it's sine squared, that means sine of h squared. And we're going to put it over an h, but since the h will now be squared, since we have the parentheses extending over both, we need to compensate by putting an h squared in the numerator. What we did was phase match it, so we have the perfect identity that will be a limit of 1. We still have the second fraction, which will be cosine of x times the sine of h over h. In this first fraction, one of the h's cancels, so we will cancel those out. Now let's just write what we have left over. Limit as h goes to 0 of negative h sine x over cosine of h plus 1. And then we have sine h over h quantity squared plus the cosine of x times the sine of h over h. Now as h goes to 0, the sine of h over h, those become a 1. So we have a 1 here, and we have a 1 here. And now we can plug a 0 into the remaining h's. So we'll have negative 0 sine of x over cosine of 0 plus 1, and then plus cosine of x. That first fraction, negative 0 times sine of x, all of that's just a 0. Cosine of 0 is a 1. 1 plus 1 is a 2. And 0 divided by any number that's non-zero is 0, so we have a 0 plus a cosine of x, and so overall we're getting a cosine of x. That's why the derivative of sine x is the cosine of x. The other thing we need to do is plug in a 0, f prime of 0, which will be the cosine of 0. Cosine of 0 is a 1.